Hello, and welcome everyone to the very first episode of Jumpstart's question and answer session for CSEC Math. So, we received a lot of requests for questions that you guys wanted to see solved, and we selected one of them. This week, we'll be looking at number 8 of May 2019's paper 2. Okay, so the first part of it, part A, we are given two functions, fx and gx. And A part 1 asks to state a value of x that cannot be in the domain of f. What does that mean? Cannot be in the domain of f. Well, they're asking for a value of x that's going to result in the function fx being undefined. How does a function become undefined? If you were to divide by 0. So if you were to check in your calculator now and you were to take any number like 3 divided by 0, for example, you're going to get undefined. So you can test it out if you want to. So what we're basically looking for is the value of x that would make the denominator of fx equal to 0, because that value cannot be in the domain of f. Okay? So we just have to make x the subject of the formula here. How we do that is by moving everything that's not x over to the other side of the equation. So we'll start with the 1 and breaking this down very slowly and taking it one step at a time. So we're going to get 0 minus 1. For those of you who struggle with this bit, if you're moving something from one side of the equation to the other side, whatever operation you're performing on the left hand side, in this case we are adding 1. When you move it to the other side of the equation, you do the opposite. So when we move it to the right side, it will be minus 1. So we have 2x is equal to 0 minus 1, which is just equal to minus 1. And x now, we need to now move the 2 over to the other side. And what is the operation that we're performing with the 2? X on the left hand side here is being multiplied to 2, which means when we move 2 over to the right hand side of the equation, where the minus 1 is, we are going to be dividing by 2. So this therefore is the value of x. X is equal to minus a half. That would make this equation here 2x plus 1, which is also the denominator for fx, equal to 0. So x cannot be minus a half. Okay, it cannot be in the domain of f. So the next part of the question, part 2, we need to find fgx. So just a quick refresher for those of you who may need it. Let's look at gx up here, right? So if we were to say g2, how would we figure that out? So gx up here is equal to x minus 3. g2 means you simply substitute x with 2, the number 2. So instead of x minus 3, as we see up here, we are going to have 2 minus 3, which is equal to minus 1. So the value of g2 is equal to minus 1. Composite functions, which is what you have with fg of x, may look complicated, but it's the same principle. Instead, however, of substituting a number for x, what we are going to be substituting into fx. But what we are substituting into fx, instead of x, we are going to be replacing the x in fx with the entire value of gx. So what does that mean? So fx on top of here, let me write it again, is 9 over 2x plus 1. F of gx would mean I am going to substitute the whole of gx into f of x. So basically, wherever I have x in this equation, I'm going to put gx. And what is the value of gx? If you go back to the top, it's x minus 3. So the whole of gx must be substituted wherever you see x in the original equation, fx. Right? We have this plus 1. So this is what we end up with. And we simplify it, of course. So we have 9. Then remove the brackets by multiplying the number on the outside, which is 2, by each thing inside the brackets one at a time. So that gives us 2x minus 6 plus 1, which simplifies to 9 over 2x minus 5. And that's the end of part 2. So now we are going to move on to part B of this question, which is to find f inverse of x. So f inverse of x. So if you recall, the original equation fx that we were given earlier is equal to 9 over 2x plus 1. Now I like to replace fx with y, or g of x or h of x, just replace it with y, because when you're finding the inverse, it's just easier to think of it this way, right? So if instead of fx, I'm just going to say, okay, this is y. So if I rewrite that equation, what I'm going to get is y is equal to 9 over 2x plus 1. So now what? Now we find the inverse. How do we do that? So the first step is we are going to interchange x and y in this equation. So what that means is wherever I see y, I put x, and wherever I see x, I put y. So up here, instead of y, I'm going to say, okay, that is x. And on the right hand side, I have 9 over 2y plus 1. Now we make y the subject of the formula again. So I'm going to go up here. Okay? So we want y to be the subject of the formula. I'm going to write it again. X is equal to 9 over 2y plus 1. How do we do that? Okay, so we need to get y on its own on one side of the equation. That's what making it the subject of the formula means, right? But first we need to deal with this fraction, because when you have fractions and you're trying to make something the subject of the formula, it's going to be very difficult to deal with. So we want to get rid of this fraction here. So the denominator at the bottom here is 2y plus 1. And what are we doing with the denominator here? We are dividing 9 by 2y plus 1. So the operation being performed on 2y plus 1 is divide or division. So when we move this 2y plus 1 over to the other side of the equation, the operation we need to perform is multiplication. So that is the same thing as saying x multiplied by, I'm putting it in brackets because it means the same thing, 2y plus 1 is equal to 9. So now the next step is we need to expand these brackets, which means that we multiply x just like we did before earlier on in the question by every term inside the brackets one at a time. So let's take the first set. X by 2y would give me 2xy. Then x by 1 would simply give me x, or 1x, where the 1 is understood. And that is equal to 9. But remember, we're still trying to make y the subject of the formula, which means that we need to move everything that is not y over to the other side of the equation. So the easiest thing to move here would be the plus x. And again, we are adding x on the left hand side. So if we are moving this x to the right hand side, we have to do the opposite of the operation being performed on the left. And that opposite is to subtract it. So we're going to end up with 2xy is equal to 9 minus x. So now we're trying to get y as the subject of the formula, which means we need to move this pesky little 2x on the left here over to the right as well. And what are we doing with this 2x? This is like the same thing as saying I'm going to write it on the left here, 2x multiplied by y, not so, where it's being multiplied to by y. So when we move it over to the right hand side, that means that we can divide by 2x. So it's 9 minus x divided by 2x. And this new y is the same thing as f inverse of x. So therefore, f inverse of x is equal to 9 minus x over 2x. Alright, so now we are moving on to part B of question 8. So we're switching gears a little bit. This question deals with measurements and some algebra as well. So we are given two rectangles here. We have a small one inside that's shaded, and then we have an unshaded one, a larger rectangle here, right? They told us we know the length in this case, which is 2 centimeters plus 3x, and we know the width as given on the left hand side here, which is 3x plus 4. Whenever you start any kind of question, as any kind of worded problem especially, you always write the information that you have before you even get started. They gave us some information in this question here by telling you that ABCD has an area of 44 centimeters squared. That is not already included in the diagram. So yes, some of it is included in the diagram, but some of it is not. So let's write this here. So let's say if we were to call this rectangle 1 and rectangle 2, right? What we know is that rectangle 1, as indicated by this A, B, C, D, so they're referring to the bigger rectangle, the area of that is equal to 44 centimeters squared. So now we have all of the information we need to start working on the first part of this question here. We need to show that the area of this rectangle ABCD, which we have just called 1, it's show that it is x squared plus 2x minus 4 equals to 0. So how do we do that? Okay, so we're talking about the area of a rectangle. And what do you know about the area of a rectangle? The area of a rectangle is equal to length by width, not so? And we know in this case, what is length? So the length in this case is this entire thing here, which is simply 3x. So let's write this, 3x plus 2, and the width is equal to this entire side on this side here, and I'm just adding up these two terms, 3x plus 4, 3x plus 4, right? So we know that the area is length by width, so I'm going to substitute these two values for length and width into my formula for the area. So the area, and I'm going to put subscript 1 because we're talking about the larger rectangle here, is equal to 3x plus 2, which is the length I'm substituting, multiplied by 3x plus 4. And we know what that actually is because up here we already established and wrote down the information we were given, which is that the area of this first rectangle is 44 centimeters squared. So we know that is equal to 44. So now what? Let me scroll down a little bit. Okay, so now we expand. Now what does that mean? We are going to remove these brackets so we can simplify things a little bit. To do that, just like when we had one single number on the outside and we had to multiply that number by everything in the brackets, we do the same thing here. So, but there are two terms now. So we're going to take the first term here, 3x, and we're going to multiply 3x by everything inside the other brackets, 3x plus 4. Then we're going to take this next term here. We have a plus 2. We're going to write that down, and then we're multiplying that by everything in the second brackets again, which is 3x plus 4. And I'm just going to bring it out equal to 44 because we know it's equal to 44. So now what? So now we expand these. So we have 3x here multiplied by 3x, and that gives us 9x squared. Then we have 3x multiplied by 4, and that gives us 12x plus, we're bringing down the plus because that's what we have on top of here, 2 by 3x, which is equal to 6x. Then we do 2 by 4, which is equal to 8, and that is equal to 44. So now we can simplify this a little bit more by, because if you look at what we are trying to prove here, we have to say that it's equal to 0. And right now we have a whole 44 on the right side, so we want to make sure we have nothing on that side. So we want to bring the 44, take the 44 over to the left hand side. So let's do that. We have 9x squared plus, let's simplify this, 12x plus 6x simplified to 18x plus 8. And then if I'm moving the 44 What is understood here, but it's not written, is that this is plus 44. So you're adding 44 on this side. So when I move 44 over to the left side of the equation, I need to do the opposite, which is minus 44. So this becomes a minus 44, and we are left with 0. So let's simplify this a little further. We have 9x squared plus 18x plus 8 minus 44, and that gives me actually minus 36, which is equal to 0. So now what? Are we done yet? No, because they're asking us to show that it's x squared plus 2x minus 4 equal to 0, not 9x squared and all of these things. So if you look at this, if you look at each one of these terms here, you can notice that all of them could be divided by 9. They all can be divided exactly by 9. So if I were to then divide everything here, because when you have an equation, as long as you perform the exact same operation on every item in the equation, every term, nothing changes. If I'm dividing by 9, every term gets divided by 9. So when I divide 9x squared by 9, the 9's cancel. So this is what it looks like, over 9 plus 18x over 9. I'm going through every step for you guys. 36 over 9 is equal to 0. Let me scroll along a little bit more. Right, so then of course the 9's here would cancel. This would cancel to give you 2. This would cancel to give you 4. So what you're left with is x squared plus 2x minus 4 is equal to 0, which is exactly the same as what we were asked to show. So you could just write a little proven next to it to indicate that you're done. Okay, so now we are moving on to B, part 2, where we are asked to calculate to 3 decimal places the value of x. So I just rewrote it over here. This is the equation, the quadratic equation that we just solved, that we just came up with at the end of the last part. So now we need to find the value of x, which is the same thing as solving the quadratic equation. So in this case, we need to use the quadratic formula, right? So just a quick refresher what the quadratic formula is. We have, if you were to have a general quadratic equation in this form here, where a is the coefficient of x squared, which is another way of saying it's just whatever number is in front of x squared, b is the coefficient of x, and c is the constant. The quadratic formula is, I'm just going to write it here for you guys again, is equal to b plus or minus the square root of b squared minus 4ac over 2a. And whoops, I made a mistake. It's minus b. I forgot this minus sign right here. Alright, so it's minus b plus or minus the square root of b squared minus 4ac over 2a. So the equation we have is up here, x squared plus 2x. So I'm just going to say, whenever, again, whenever you have any kind of problem, you always write the information that you're given before you even start to work the problem. This is going to help you avoid making errors. Okay, so in this case here, what is a? For our equation, the coefficient of x squared here is 1, and then b, the coefficient of x in this case up here is 2, and then c, the constant is minus 4. Know that it's minus 4 because this sign in front of it is not for decoration. You need to include that as well. Okay, so now we know a, b, c, we know our formula. It's now just to apply it. So to solve this now, what we get is minus 2 plus or minus the square root of 2 squared minus 4 by 1 by minus 4, right, all over 2 by 1. So what does that simplify to? This gives me minus 2 plus or minus the square root of 4 minus, and then I work out what's in the brackets. What's in the brackets? I have 4 by 1, which is 4, and 4 by minus 4 will give me minus 16, because a positive by a negative will give me a negative. So what's in the brackets works out to give me minus 16, and that is all over 2. I'm coming back to the left here now. Now, if you look over here, we have 4 minus minus 16. And if you remember the rules, a minus by a minus would give you a plus. Okay? So this is actually going to work out to be minus 2 plus or minus the square root of 4 plus 16 over minus 2. Oh, how did I get a minus 2? My apologies. This was actually supposed to be positive 2. Okay? Alright, so let's simplify this. So we have minus 2 plus or minus the square root of 20 over 2. Right? So therefore, x is equal to, you can take the two of them. We have two possibilities. We have minus 2 plus the square root of 20 over 2, or x is equal to minus 2 minus the square root of 20 over 2. And the first answer is going to work out to be, they ask you for 3 decimal places, 1.236 centimeters. And the second one, I won't even bother to work it out. The reason for that is because we are talking about the length of the side of a rectangle, and x is not going to be a negative number, and this number on this side here is going to be negative because you have minus 2 minus something else over 2. So you know this is going to be negative, and we could eliminate this one time as a non-viable or unviable solution. So this is a solution here. X is equal to 1.236. So for our final part, B part 3, we need to calculate the perimeter of the unshaded region. Remember, we had 2 rectangles, one inside the other. We had the big rectangle, and then we had the smaller rectangle inside, which is the shaded region. But this question is asking us to find the perimeter of the unshaded region. So the perimeter is simply, if you look at it together, just follow the cursor. Simply this side plus 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 this side. So we're totally ignoring this part, right? So the easiest thing to do in this case would be to write the information that we have. So we know this side at the top here, don't we? It's going to be the same exact dimension as the bottom here. So let's write that in. So let's write in the information that we do have. So we know that this side is 3x plus 2 because it's the same as the bottom here. And we know that this side here is 3x plus 4. Not so? And don't we also know this side? Because if from here to here is 4, then this would also be 4. And if from here to here is 2, it would be the same as the bottom here, which is 2. And we know that this side is 3x. So the perimeter of the unshaded region, therefore, let me write it here, of unshaded region is equal to, we're just adding them up. We're going to start with this one here, and we're just going to work our way all the way around. So this first one is equal to 3x plus 2. Alright, now for the next side, plus 3x plus 4. Okay, where are we now? Oh, we have this bit at the bottom here. That is 3x. Alright, and then we're going up now because again it's the unshaded region. So we have this part here, which is 4 plus 4. Then we have this bit on top of here. That is 2. And we are almost at the end. We have just this bit to complete this unshaded region here, which is 3x. Right, so this looks super complicated, but it's not. All we do is gather the like terms. So we have 3x plus 3x plus 3x plus 3x. You could also have just said 3x by 4 because you literally have 4, 3x's, but I'm just going to write it out like this, and then we start putting the numbers together. Plus 2 here, plus 4, plus 4, plus 2. So we have this. So how does this simplify? Alright, so all of these 3x's here will simplify to give you 12x. Okay, 3 plus 3, 3 plus 3 plus 3, that's how I got that. And then we have plus 2 plus 4, 6 plus 4, 10, so we have 12 here. So we know that the perimeter is equal to 12x plus 12. But what else do we know? We now know the value of x. So recall that we have a value of x. X is equal to, right on top here, 1.236 centimeters. So now we can substitute it to get the perimeter is equal to 12 multiplied by 1.236 plus 12. And using BODMAS, we of course would work out the multiplication first before we attempt to do the addition part of it. And that works out to give you 26.832 centimeters. And that brings us to the end of the question and the end of this episode. Thank you for watching, and we hope to see you guys here for the next session in a week.